Hello students, welcome to my channel Maths Hub. So today in this video, I'll tell you about orthogonal trajectory. Now orthogonal trajectory is composed of the word orthogonal and trajectory. Orthogonal means when two things are perpendicular to each other and trajectory is just a path, right? So orthogonal trajectory means when a set of family of curves intersects the other family of curves at right angles, we say that they are orthogonal trajectories. Right. So here in this curve, you can see a set of ellipses and a set of parabolas. So you can clearly see that the set of parabolas is perpendicular to the set of ellipses. So we will say that the parabolas and the ellipse, they are orthogonal trajectories of each other. Now the question here is that if one family is given to us, how do we calculate the other family of curves which are orthogonal to each other? Right? So the working rule says that first of all, from the given family of curves, frame the differential equation, and we know how to frame a differential equation. We need to eliminate the constant c by taking the derivative, and by eliminating c we will be able to get a differential equation in terms of dy by dx, right? So now in the next step, what is to be done? We will replace dy by dx with minus dx upon dy. Why so? We know that when two things are perpendicular, their slopes, the product of their slope is always equal to minus 1. So if I know the slope is the derivative, right? So if I know the slope, suppose if I know the first slope is dy by dx and I want to calculate the second slope, how will I calculate m2? M2 is minus dx upon dy, right? So that is the logic why we are replacing dy by dx with minus dx by dy. So you will get a new differential equation to solve that differential equation. And by solving the differential equation, whatever solution we get, that will be the required orthogonal trajectory, right? So let us apply this concept in the following exercise and let's understand how do we calculate the orthogonal trajectories. So we are given a family of hyperbolic curves given by the equation y is equal to c by x, and we need to find out the orthogonal trajectory for this curve. So the first step is, so from the given curve, let us calculate the differential equation. So let's take the derivative. So dy by dx is equal to c upon 1 by x, the derivative becomes minus 1 by x square, right? So let's eliminate c. So from the given differential equation, I know that c is equal to y into x. So let me substitute here. So we get minus yx upon x square. One of the x gets cancelled and we get minus y by x, right? So this is my differential equation. Dy by dx is minus y by x. So in the next step, we will replace dy by dx with minus dx upon dy. So this is equal to minus y by x. So you can see that minus gets cancelled. And now this is a first order, first degree differential equation. And by now you know how to solve it. So how we are going to solve it? You can easily see that the variables can be separated on both sides. So x dx is equal to y dy. So on integrating both sides, what do we get? We get x squared by 2 is equal to y squared by 2 plus constant c. So from here we can say that x squared minus y squared is equal to some constant c dash. So this equation, the curve that we get here, this is an orthogonal trajectory to the given curve y is equal to c by x, right? So I hope the method is clear to everyone. So now let's move on to the next exercise. So here the diagrammatical representation of the previous question. So you can see that the given family of curve was y is equal to c by x, and you can see the faint blue lines, they are representing the curves y equal to c by x, and the dark blue lines here, the hyperbolic equation x square minus y square equal to c are represented by these equations, and you can clearly see that to the given family of curves, the new family of curves are being orthogonal, right? Okay. So let's proceed to the next exercise. And in the next exercise, we are given the family of straight lines y is equal to cx. And we need to calculate the orthogonal trajectory to this curve. So again, let's repeat the process. So let's frame the differential equation. So dy by dx is equal to c. So here I need to replace c, eliminate c. So c is y by x. So let me replace it by y by x. So in the next step, let's replace dy by dx with minus dx upon dy. This is equal to y by x. So now you can separate the variables and we will get y dy is equal to x, in fact minus x dx. When you take integral, this is variable separable method, y square by 2 is equal to minus x square by 2 plus constant c. So from here we get y square plus x square is equal to c. Right? So I hope the method is clear to everyone. So now you can try the next question as an exercise and I'm giving you the answer. So do try the question and do let me know in the comment section whether you were able to solve it or not. Right? So this is the method of calculating the orthogonal trajectory when your family of curves is in x and y system. That means the Cartesian system is given to us. Right? But when the coordinate system changes, if we have a polar system means when the family of curves contain the variables r and theta, then how do we calculate the orthogonal trajectories, right? So you will be given a function in terms of r, theta and constant. So first of all, we have to calculate the differential equation. So we'll take the derivative of r with respect to theta and we will frame a differential equation in r, theta and dr by d theta. Then in the next step, we will eliminate or we will replace dr by d theta with minus r square d theta by dr. So this is the replacement that we need to remember. And then after replacing it, we will get a new differential equation. You need to solve that differential equation. And whatever solution you obtain from there, that is the answer to your orthogonal trajectory. Right? So let us try to do one problem in this. So we have to find out the orthogonal trajectories of the cardioids are equal to a into 1 minus cos theta. So let's take the derivative of this expression. So we will get dr by d theta is equal to a is constant. Derivative of 1 minus cos theta. So derivative of 1 is 0. And when you take the derivative of minus cos theta, what will you get? Derivative of cos theta is minus sine. So you will get sine theta here. Right? Eliminate a and we will get sine theta. A is r upon 1 minus cos theta. Right? So can we further reduce this term? Let's see. We can write this as 2 sine theta can be written as 2 sine theta by 2 cos theta by 2 and 1 minus cos theta can be reduced as 2 sine square theta by 2, right? So 2 cancels out, 1 sine gets cancelled and we get the term as r cot theta by 2. So we have dr by d theta on this side. Dr by d theta is equal to r cot theta by 2. So let's make the replacement. Let's replace dr by d theta with minus r square d theta by dr. This is equal to r into cot theta by 2. So one r gets cancelled and now let's separate out the variables. So you will find you will get dr by r is equal to, you will get d theta by cot theta by 2. So that can be written as minus tan theta by 2 into d. So now we can integrate both sides and on taking integral, we'll get log r. Now what is integration of tan theta by 2? Integration of tan theta by 2 is, you can write tan theta by 2 as sin theta by 2 by cos theta by 2 and you can see that by substitution method, if I substitute cos theta by 2 equal to t, I'll get the derivative as sin theta by 2. So that will get cancelled and it will become log cos theta by 2 and we will get a 2 along with it, right? Plus log c. So I can write this as log c. So from here we get r is equal to c into cos square theta by right? So that becomes my curve or the orthogonal trajectory to the given family of curves of the cardioid, right? So I'm giving you one more exercise to try in polar coordinates. So you have to find out the orthogonal trajectory for the family of curves r square equal to c sine 2 theta. I'm also giving you the answer. The orthogonal trajectory will come out to be r square equal to c cos 2 theta. So just try this and do let me know in the comment section if you are able to solve it, right? So that's all for this video. If you like the video, do hit the like button, and those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video, and believe in yourself and you will be able to succeed. Thank you so much.